In this example, I'm going to show you how to solve a quadratic and irrational inequality because they're very similar. When you have a quadratic inequality, that's when you have a quadratic expression less than or greater than 0. What you want to do is you want to try to find the roots of this quadratic expression. So you're going to set the quadratic equation equal to 0, and then you're going to solve it. And you should know how to do that by now. So I factored it, and I got 5x plus 2 times 3x minus 4. And then if I set that equal to 0, I get negative 2/5. And then if I set that equal to 0, I get 4/3. Now, I want to know when this expression is negative or 0. Now, negative because what's less than 0 mean? Less than 0 means negative. So I want to know when this expression is negative or 0. Well, we know when it's 0, it's equal to 0 when x is negative 2/5 and 4/3. But where is it negative? Well, what we're going to do is we're going to actually break the number line up at those two values, because that quadratic expression can only change sign at those values, negative 2/5 or 4/3. So, and actually you can call these numbers critical values if you like. But so these are the values where that expression can change sign. So let's see. So all I have to do, since these are the only places where the sign can change is when it crosses these numbers, then all I have to do is just pick a number that's in these intervals that these two numbers divide the number line up into. So negative 2/5 and 4/3 divide the number line up into three regions. All the values less than negative 2/5, all the values between negative 2/5 and 4/3, and all the values greater than 4/3. So that expression is going to have the same sign for all numbers in here, and it's going to have the same sign for all numbers in here, and it's going to have the same sign for all numbers in here. I just need to know what that sign is. Is that sign positive or negative? So the way I figured out, I just simply get a test value in each of these intervals. So find a number less than negative 2/5. Don't make it too difficult. How about negative 1? Now if I plug negative 1 into this expression, you can plug it into the non-factored form, or you can plug it into the factored form. I like to plug it into the factored form because I know what the signs are going to do when they multiply together. So if I plug negative 1 into this term, I'm going to get negative 5 plus 2, which is negative. And if I plug negative 1 into this term, I'm going to get negative 3 minus 4, which is negative. So I know a negative times a negative is positive, so I'm going to get a positive. So that tells me that all the values less than negative 2/5 make this expression positive. So obviously those are not going to be the answers I'm looking for. Now, how about between negative 2/5 and 4/3? Well, a number between there would be 0. So let's plug 0 in. Well, if I plug 0 in this first factor, it's going to be positive. If I plug 0 in the second factor, it's negative. And so I'm going to have a positive times a negative, which is a negative. So that interval from negative 2/5 to 4/3 is part of my solution. Now, just to make sure, we need to check, see if this is going to be part of the solution as well. So let's pick a number greater than 4/3. How about 2? So let's plug 2 in. If I plug 2 in, 5 times 2 plus 2 is positive. 3 times 2 minus 4 is positive. Positive times positive is positive. So I'm going to get a positive. So all the values in this interval make the expression positive. Well, remember, I wanted to know when the value was negative. So I need to use the middle interval from negative 2/5 to 4/3. But I also wanted to know when it equals 0. So I have to include the negative 2/5 and I have to include the 4/3. So rather than just saying negative x is greater than negative 2/5 and less than 4/3, I actually have to say x is greater than or equal to negative 2/5 and less than or equal to 4/3. Now you can write this in interval notation as well. And if you want to see an interval notation, it would look like this. -2/5, comma, 4/3. But basically, any number from -2/5 to 4/3 will make this inequality a true statement. Now, before I move on, let me just tell you, these signs don't always alternate, so make sure you check the intervals here to see if the signs are positive or negative. And then one last thing, obviously if this had said, well, a couple things. If this had not said less than or equal, if this had just said less than, then I wouldn't use the equal to here. And then of course I would use parentheses instead of brackets here. Now another thing, if it had said greater than or equal to, then I would have used the outer two regions. I would have had the solution for all values less than or equal to -2/5 and x is greater than or equal to 4/3. So, you know, don't have time to show you every possibility, but hopefully this will help you with quadratic inequalities. Now, rational inequalities work in a similar fashion. There's just one thing you have to remember. You have to keep your eye on the domain of a rational inequality. Like here, x minus 5 over 2x minus 3. Well, since the denominator can't be 0, you know that x cannot equal 3/2 because that would make the denominator 0. So that cannot be part of our answer. Okay, so keep that in mind because it'll come into play at the end. Okay, so here I have a fraction x minus 5 over 2x minus 3 is greater than or equal to 0. Well, the only place that a fraction can change sign is at a number where that makes the fraction 0 or a number that makes the fraction undefined. And I've already told you what that number is, 3/2. So basically what I'm going to do here is I'm going to divide the number line up into 3 regions again. 3 regions because I only got 2 critical values. And the 3 regions are going to be broken up using 3/2 and 5. Okay? 3/2 and 5. So I'm going to play the same game I did before. Everything less than 3/2, I'm just going to use 0 because 0 is less than 3/2. Now if I plug 0 into this expression, the top's going to be negative, the bottom's going to be negative, so I get negative over negative, which is positive. So I know that if I pick a number less than 3/2 and plug it in, it's going to make this expression positive. Now I need a number between 3/2 and 5. Well, 2 would be a good number. You could use 3 or 4 as well, but as long as it's between 3/2 and 5. So if I plug 2 in, 2 minus 5 is negative. 2 times 2 minus 3 is positive, so I get a negative over a positive, so that quotient is going to be negative. And then I need a number greater than 5 to test this interval, so if I'll use 6. 6 minus 5 is positive, 2 times 6 minus 3 is positive, so a positive over positive is positive. Now, on this one, I wanted to know when the expression was positive or 0. Now, remember, it only equals 0 at 5, not at 3/2. Remember, it's undefined at 3/2. So 5 makes it 0. Now, let's see what makes it positive. All the numbers less than 3/2 make it positive, and all the numbers greater than 5 make it positive. So I want all of the numbers less than 3/2, but I don't want to include 3/2. Notice I didn't put the equal to there, because remember, 3/2 doesn't make it equal 0, it makes it undefined. And then I also want to include all the numbers greater than or equal to 5. And of course, I want to include 5 because 5 makes it equal 0. So this time it's 2 regions, everything less than 3/2 and everything greater than or equal to 5. And that's pretty much I think I got sidetracked there, but anyway, sorry about that. But anyway, that's the solution for this problem. And I believe that pretty much ends the discussion about equations and inequalities. I'm going to start talking about functions in the next series. So I'll talk about problems that involve functions in the next series of examples.